This one?
No, I'm talking about if you go,
These two?
vertically on the other side.
Yeah,
And there are two different
this edge and this edge
they will be.
will never intersect. Are they parallel? No. Should they have to be on the same plane?
According to the definition.
Can we draw a plane that includes both of them? Yes. So there is a plane, it's not on here, but there is a plane that includes both of these line segments. You could go, show us, Mara, what you're thinking?
Like diagonally. A plane, you wouldn't have to necessarily be flat
Okay.
this way, but it could go this way, right?
It could go like this. So could there be a plane that contains both of these?
Yes.
If that's the case, are they parallel?
Yes.
Right?
Because they would be on the same plane and they would intersect.
Equidistance apart.
Same plane and never intersect. Okay, that's what I keep hearing. So these two are on the same plane. Will they intersect? Eventually. Are they intersecting now? No. Many times kids will think, as Donna was saying, these two are parallel because you stop at that definition of they don't intersect. These don't intersect right now. These don't intersect right now. So what is the key part of that definition that most teachers leave out that is so important? It's equidistance apart. Equidistance apart. So these 2 points are this far apart. These 2 points are not the same distance apart as these two. How about these two and these two?
Those look like they might be, but I think when you look at the outermost points, those don't match all the others.
Okay, she used the word matching. So there has to be a corresponding point in the other line segment or line, right? So this point corresponds to this point, we could say?
Right.
And they appear to be about, what, 8 inches? This point corresponds to this point, we could say? And they appear to be about?
They're about, I think they look about the same.
They look about 8 inches. We're supposing a lot now here.
Right.
This point, let's say the midpoint corresponds to this midpoint. They appear to be,
About this.
oh, so they're parallel. They're parallel.
But no, because when you look at your last 2 points, the other end point of each line segment, those are not the same distance as all the other points we discussed. They are partners, because if we
You
assume,
want to come up here and point? I see you pointing.
so here's my thinking, and I could be wrong, because I'm still learning math, even though I teach it. But we're all doing it. So if you're saying that these 2 points are partners, and these 2 points are partners, and these 2 points are partners, but if I look at these 2 points as possibly being partners, and these 2 points, then it would not be parallel, because these 2 points are a closer distance than these 2 points. Their
Makes sense to
distances
you?
are not the same.
Y'all agree with her? Everybody does? Some of you are non-committal. Tim?
Yes, ma'am.
You agree with her?
I agree with her if you look at the pairings that she created.
If you look
But
at
the pairings that you initially created, when you went to the midpoints, to me, they seem farther apart than all the other points together. And then as I look at that, I don't think they would be on the same plane because of the 2 endpoints on both right sides, this one's higher. It's not going, eventually, yes, those 2 endpoints.
Okay.
Eventually, the endpoint on with your left finger is going to run into that endpoint that's right there.
It
So
appears to, yeah.
It appears that's going to, therefore, they wouldn't be parallel because they both line segments wouldn't be able to touch.
Okay, so really there's 2 parts of that definition of parallel, and both are important. 2 parts. What are those 2 parts? They have to be what and what?
In the same plane.
In the same plane, or a plane that can be created. And there's 3 parts, but that wasn't even what I was thinking. So there's 3 parts. What else?
Equidistance apart.
Equidistance apart for the entire length of the line segment. And what else?
Never.
Oh, they don't intersect. So if they're equidistance apart, they are
That
not
would
going
imply
to
never
intersect.
touching.
Right? So equidistance, maybe there is just two parts, equidistance in the same plane.
Is that coplanar?
Coplanar, yeah. Yeah, the word is coplanar. Okay? Straight on parallel. I don't know why parallel is so difficult for children, but it appears to be that difficult for children. And for us, you know, we're just like, Tanya, it's like this, you know, what's the problem here? Yes, ma'am.
I was gonna say, my kids were having a problem with parallelograms versus like rectangles. And I actually had them use two different color highlighters, and it seemed to like click all, they would never go together.
Oh, well, good, good. So, yes, ma'am?
Can we, is it wrong for us to teach them to, okay, here's your line, extend it out with a pencil? Extend this one out with a pencil, is that wrong?
It is not wrong at all. That's a really great strategy. Really great strategy. So I have a question about what she was saying. She talked about parallelograms and rectangles. What's the difference in them? Nothing.
Parallelograms are angled.
Okay, let me back up. I want a definition of a parallelogram. The shortest, most concise definition you can give me, Michelle.
Two sets of parallel lines.
Two sets of parallel lines.
Rectangles.
Okay.
To make it be closed, not.
Okay, so it's a quadrilateral.
Okay, quadrilateral with two pairs of parallel lines.
Quadrilateral, two pairs of parallel lines.
Right.
Okay? This is on your post-test, by the way. Quadrilateral, two pairs of parallel lines. What is a rectangle in the shortest, most concise definition?
Parallelogram with four right
A parallelogram with right angles, correct?
Yes.
So every rectangle is also a parallelogram, it's a subset. Every parallelogram may not be a rectangle. That's like, you know,
Every square is a rectangle, but not every rectangle is a square.
yes, ma'am. Yes, ma'am. Yes, ma'am. Or all boys are people, but not all people are boys. Right? Yes, ma'am.
What I did to help kids make that classification between parallelograms and rectangles and squares and rhombus is I just cut out like thin strips of poster board and I punched a hole. So I measured the same, you know, for our one pair and then for the rectangle, and then I punched holes and put a brad in it. So you could hold it up and it was a rectangle, and then you could just tilt it. And they could actually see it move, that the side links aren't changing.
Yeah.
So we talk about what's changing from the parallelogram to the rectangle, and it's actually the angles that are changing. So that helped my 6th and 7th graders see the classifications between the two.
You
If
can
they could
actually buy
physically
those.
move it.
Yeah. You can actually buy those, but, you know, making them.
I made them. I made them.
In the book, the textbook that I gave you, that page on quadrilaterals that we talked about, it has diagrams of those things. So, thank you, Karen, for reminding us. because-
Dr. Browning, I think the other disservice that I know I've done to children is that whenever I show them parallel lines, whenever we discuss parallel lines, they're always the same length.
Yeah.
Yes.
And
Yes.
so, and again, that was something that kind of
But
smacked
they're
me in
always
the
the same
face.
length in the book too.
Right, and that
Absolutely.
smacked me in the face this year because I would have kids tell me that trapezoids did not have any parallel lines.
Yeah.
And they were under the assumption that the top and the bottom were not parallel because they weren't the same length. Well, they can be parallel, they're not the same length. So we had to go back to that definition of, are they ever going to touch each other? Are they equidistant apart? You know, will those two lines, if I extend each line out completely, will they ever run into each other? No, they won't. They're equidistant. So,
And that's a great point, Donna, thank you. And if I were y'all, I would be writing that down. Because the textbooks, because of the typesetting and the ease in typesetting, they do some things that really undermine mathematical
Yeah.
thinking. And one of them is always showing parallel lines as the same length, line segments as the same length. So you have to be really up on your game and say, now, boys and girls, this picture shows this. However, what if this would happen? Don't tell them that it would still be parallel if that was longer. The question to do then is, what if this one was longer? Are they still parallel? Exactly, exactly. So that's when you have to go back to your corresponding points You know, if every two pair, of course, every pair, I cannot talk today for some reason. Every pair of corresponding points has to be the same distance apart. Okay, same distance, equidistance. Where's my food? You come late, you gotta bring food. Okay, so we looked at these line segments, number one, and what can you tell me about these two? They do intersect.
They appear to be perpendicular.
They appear to be bisectors, we're not sure. But they appear to bisect each other.
They appear to be perpendicular.
They appear to be perpendicular. Now, this is where high school geometry got some of my friends, because sometimes they would appear one way, but they really were not.
Right.
And so that confused my friends a great deal. You can't always go by appearances, all right? So we think they're congruent, we think they're perpendicular, and we think they bisect each other. So if I connected those line segments, what shape would I have? A square. So then we did an activity about bisectors. If your bisectors are congruent, if your diagonals are congruent, they bisect each other and they're perpendicular, you've got a square. There's no other shape you could have. You've got a square. So what if, well, let me see what I have here. So then we talked about quadrilaterals. I'm going to not do my what if right now. We'll go back to that. Then we talked about quadrilaterals. Quadrilaterals is a big set of shapes. And what's special about quadrilaterals? Four sides. Four, of course, lateral means side. Like a lateral pass in football, we pass it to the side. Okay? And then we have our parallelograms. Parallelograms are also quadrilaterals. However, they have, what did you say? Two sets of parallel lines. From the parallelograms, we then go to rectangles. Rectangles are also parallelograms, they're also quadrilaterals, but they have to have a right angle. And then we went to the square. Squares are also rectangles, they're also parallelograms, they're also quadrilaterals. So what's so special about the square?
All sides are the same.
All the sides are congruent. All sides are congruent. And then we have trapezoids over here. They're quadrilaterals. Why are they not parallelograms?
Because they only have one set of parallel lines.
Only one set of parallel lines. If you're a math teacher, you need to not be answering me so that the science people have to think. Okay, it's very, very difficult for you to do that. Well, part of it's my fault because I'm doing what I tell y'all not to do and I'm asking for a question, for a response. Don't laugh at me because we've had this conversation many times, haven't we?
Dr. Brennan, can you read, because I struggled this year, that's where we have to get in 5th grade, is that exact diagram.
Yes.
And looking at those trapezoids and my kids, and then I didn't know how to teach it. As we looked at that definition, I should have just gone back to the actual definition of a trapezoid, but as I was getting to them to explore it, that right trapezoid, which is the one on that side, that one doesn't, and they're all about look.
They're visual.
The visual.
So where are they in that stage of Van Healy's levels? They're
Right.
at zero, that visual level.
Right, and so that one didn't look like a trapezoid. And so we had to talk about the definition of the trapezoid. So somebody help me with that definition because I cannot remember it.
What's a parallel line?
We need to not talk. A science teacher. One set of parallel lines is what she said. So a science teacher, tell her what that means. One set of parallel lines. What does that mean? You 5th graders now, y'all are both, so y'all are game. They're game for me.
I think this is where it becomes important to not have parallel lines that are the same length, because if you start teaching parallel lines of different lengths, then you can connect them and say, oh, well, this is how we get trapezoids, because parallel lines do not have to be the same length.
Okay, so that's a great suggestion. Begin with a discussion of parallel lines.
Okay.
Those that are not the same length, connect the endpoints, and you have voila, a trapezoid. So which sides are parallel here?
Your vertical line.
The left and right. So which sides are not parallel, Mark?
The horizontal.
Okay,
One is not
this one
exactly
is horizontal and this one is kind of,
Right.
sort of,
Yeah.
not really horizontal.
The other side.
Yeah, the other one, the other side. Here you go.
It's partnered.
Okay, all right.
So thank you for that, Brenna, because that was, I like that, because I struggled with that this year, I really did.
I
So-
struggled with math all my life, so I just, I tell them what it comes in my head.
Yeah, well, that's beneficial because I didn't, and so having another way to teach that really helps. Thank
This
you.
is the trapezoid you see all the time in books. This is also the trapezoid you see in pattern blocks. I love pattern blocks, however, they do have their limitations. Because this is the only trapezoid they show, whereas this is also a trapezoid. Because it fits the definition. What is the definition? Not a math person. What is the definition, Lisa? Definition of a trapezoid. Be as succinct as possible. Look at the diagram, it almost tells you. It has to be a,
A quadrilateral with two parallel?
one set.
Oh, one set of parallel lines.
Parallel lines, good. Quadrilateral with one set of parallel lines. Yes, ma'am?
Can you use pair?
Oh, yeah, you can use a pair.
Okay.
Yeah, one pair.
I didn't know if that was.
Yeah, I'm hungry, so I thought you would be able to come here.
No, the PAIR.
Yeah. Okay, so this is the, like a C-map. Remember those C-maps that you did? And we start with the quadrilaterals. And we go this way with the parallelograms, rectangle, rhombus, square. We go this way with the trapezoids, and we have an isosceles trapezoid and a right trapezoid. Isosceles means what, Jen?
I'm sorry. The isosceles triangle has opposite sides congruent, but they have to be adjacent.
Right, and this iso really means kind of like two. So we have two congruent sides, this side and this side. And those happen to be the non-parallel sides. Non-parallel sides. Okay. And then something we haven't talked about really is a kite. This is a kite, and this is a right kite. So a right kite means that it has a what? Ashley?
We talked about this last time. It has one bisector, and the adjacent sides are congruent to each other. And
Good.
one right, the top is a right angle.
Good, this is a right angle, hence the word right. And every kite has adjacent sides that are, what did she say, Denise? Adjacent sides are what? Denise?
Parallel? No.
Adjacent, what does adjacent mean?
Touch.
Next to, next to. Like, I am adjacent to Margaret, but Margaret is not adjacent to you. Adjacent is next to. So these two are adjacent. And to be a kite, they have to be what, Denise?
Congruent.
Congruent, very good. So these two are congruent, these two are congruent. This one happens to have a right angle. This one does not have a right angle.
Wait, so to be any kite, the side.
Adjacent sides
have to be congruent.
Congruent,
To
yes.
be a right kite.
It has to have a right angle. Well, one right angle if you have one. So looking at this kite figure, what else can you tell me about the diagonals?
So, which one?
Not a math person. The diagonal of any kite, any kite. What can you tell me about the diagonals? First of all, how many diagonals will there be?
Two.
Two, good. So, what else do we know about it? Do they bisect each other? I see yeses and nos. Draw a kite on your paper. So draw a kite on your paper as best as you can. Put the diagonals in there. Okay, somebody said that they bisect. Do they bisect each other? No.
Not adjacent. So go straight across.
Okay, Brenna, is your table ready?
Yeah.
Do they bisect each other?
No, one is bisected and one is not.
Okay, so on this one right here, could you come up here and show me the diagonal that's bisected?
So the one that goes across is bisected because, like, in the right angle, the
Hang on,
line
Brenda. Are y'all listening? Okay, go ahead.
So the line that goes across, the diagonal that goes across gets bisected by this line because it's a right angle, so it's guaranteed to go through this middle.
Okay.
But this line doesn't get bisected by this one because it's not in the
Okay.
they're not congruent.
So one is bisected and the other is not.
Right.
And she said, thank you, Brenda. She said that this one, the horizontal line, was bisected because this is a right angle. So if I draw these diagonals, would this shorter one still be bisected?
Yes.
Okay, so the shorter one is bisected.
Yes.
The longer one is not. What else can you tell me about those diagonals?
I think perpendicular.
They appear to be perpendicular. Yes, they are perpendicular. So if you have diagonals, and one is longer than the other, but they're perpendicular, but one of them is bisected, the shorter one's bisected, the other one's not, what shape do you have? You have a kite. You have a kite.
Can I ask a question?
Yes, ma'am?
What's the difference between saying they appear to be and they are?
Nothing for this conversation right now.
But R would, sorry, Tim.
Go ahead.
I was gonna say R would imply that we have proof, right?
Yes.
Where we've actually proven it. Appears to be is
We
saying,
hadn't
right,
measured it.
appears to be is saying, we're looking at it, we're saying, we're pretty sure that's what it is, but we don't have our, absolute proof.
Right, we've not measured. We have not measured. Tim, good
Question
point,
was
Doctor.
raised is, what is a diamond then?
There are no diamonds
A
in
rock I wear on my
mathematics.
finger.
Thank you. He knew the answer to that. There are no diamonds in mathematics. So sometimes teachers will call a rhombus a diamond just because it's sitting on a vertex. Or they'll call a kite a diamond because it's sitting on a vertex. But there are no shapes in mathematics that are called diamonds. Okay, diamonds are jewelry, okay, not mathematical shapes. Yes, ma'am.
Can someone please clarify the definition of bisector? 'Cause it's just that I think I know, but I just want to.
Okay, hang on, raise your hand if you want to clarify bisector for Ashley. Not a math teacher preferably.
I'll try.
Britta?
Okay, a bisector, the word bi, or the prefix, is meaning two. So you're cutting a line into two equal or congruent segments.
Right. Two congruent segments, two equal parts.
So if you bisect, then it should also be symmetrical?
Absolutely,
Okay.
absolutely. It has that point of symmetry. So if you bisect a line, you can fold it and it matches. Or
So basically a line segment has to intersect another line, but cut that line segment into two equal parts.
so you can see this kind of appears to be symmetric, right? Where the long diagonal would be the line of symmetry. Thank you, Tim.
Okay, kites, just make sure that they have to have two, the adjacent sides are congruent, and what's the other?
It's a quadrilateral.
Quadrilateral, with the adjacent sides congruent.
Two pairs adjacent sides are not congruent. Yeah.
This one is, so this one is not.
Oh, good question. Is a square a kite?
Does a square count? No.
What's the definition in the most succinct way you can say it, definition of a kite? And I'll let a math teacher answer this time, so.
Of a kite?
Yes,
A kite or a square?
a kite.
Okay. Oh, I thought you were asking for a square.
Oh, you want to phone a friend?
No, I'm good.
Okay. Okay, y'all talk with each other. Come up with a very succinct definition of a kite, Tim.
Two adjacent.
Very succinct.
But that wouldn't make this because
Well, no, because these two.
But it's square, not adjacent, but there
Yes, but
So adjacent side.
parallelogram would be a kite?
Did you say adjacent to these two and next to each other, they're not congruent?
No. Adjacent sides are.
Yeah.
Two sets of adjacent sides that
I mean, adjacent,
that are
Two
sharing
sets
a
of
corner.
congruent sides.
And that would make it square.
I mean, these are adjacent,
But they're not congruent.
there has to be two sets of adjacent congruent sides.
So it's a square and a kite, is two adjacent sides are congruent. And the square is the definition. Because I know those sets are congruent, adjacent sides are congruent.
Yeah, you have to have something about the bisecting, I mean, the,
But the adjacent right angles. The bisectors is
I'm glad you are, I'm not.
Okay, you got about 30 seconds?
They're congruent though, the bisectors and the square.
They're not congruent here, so do you have to say something about that?
See, that's an I would say yes. So you don't know what just the definition of a kite. An adjacent side of
Well, I don't know.
Because ideally a square or a rhombus is not.
Okay, let's come back together as class.
It's just for Genesis.
3, 2, 1, together. Okay. Rochelle says she has an answer now.
Okay, for the kite.
What she does.
2 sets of adjacent, congruent, wait, I forgot quadrilateral with 2 sets of adjacent, congruent sides.
Okay, so let's see if we agree. Quadrilateral, absolutely. 2 sets of adjacent, congruent sides. Agree? Yes. So let's move to the square.
With one diagonal bisected diagonal arm.
Normally, when we name shapes, we don't talk about their bisects or
Okay,
diagonals
so-
at all, do we? Not normally, okay?
Well, this is abnormal, so we're talking about it. Sorry.
Okay, so here we are, she said quadrilateral. 2 sets of adjacent congruent sides. So let's move to the square. Quadrilateral, does it have 2 sets of adjacent congruent sides?
Yes.
Does? Within a rhombus, quadrilateral, 2 sets of adjacent congruent sides.
Yes.
So squares and rhombi are also kites?
No, that's why we added the bisector.
So to determine, if you're talking about diagonals, okay? The diagonals of a square, they are congruent. They bisect each other and they're perpendicular.
Yes.
The diagonals of a rhombus, which of those 3 characteristics fit? Are they congruent?
Yes. Yeah.
The diagonals of a rhombus, would they be congruent?
Yes.
I hear yes, I hear no. Why no?
One of the diagonals would be longer than the other.
It depends.
Why?
Well, since it's, it's a parallelogram with all the same sides, but since it's kind of slanted, the distance from one of the opposite vertices is going to be shorter than the other one.
Okay, so I want you have rulers in your basket. Draw a rhombus. Draw the diagonal and measure.
The right angle is smashed by the square,
If it has 4 congruent sides, then it'd be right.
It doesn't have to have 4 right angles. But all the angles, if the sides are congruent, would all the angles be congruent?
That's a good question.
I don't think so, because looking at a parallelogram. Because you can do the opposite angles, but not. Those are definitely not the same length. I shut down when I got this, but it turns out. And that would, to me, that would affect. I would think that would affect the
You're
life.
talking to me, and you should be talking to. Okay, what you're saying is great. Just put it down.
I think it depends on the angles, whether or not it's
In my yard,
then I would think the less chances.
But the inside is the same, even with it slanted, the sides are congruent. So wouldn't it make, even though it's slanted, any which way, the sides are still congruent, making the inside, the bisector is work. You've done a good job, I'm not even gonna it would not help me.
what is the difference between a rhombus and a parallelogram?
Because parallelograms only have two.
There's two.
No, but rhombus have 4 congruent sides, whereas parallelograms only have to have 2, opposite.
All sides.
Okay, so then that's
Right angles.
It's, we talked about the rhombus.
But square,
That's why a square is a rhombus.
Okay,
Yes, definitely not a square. Exactly. We need a square.
and not always, sometimes.
And this one.
The rhombus
And the sides are all.
Let's come back together. Okay, on 3, 2, 1, are we together? Okay. I'm such a pig. So, okay, so we're trying to determine if a rhombus is a kite. We're also trying to determine if the diagonals of a rhombus are always congruent. Is that what we were working on? Okay, so you had to draw a rhombus. What is the definition of a rhombus? A quadrilateral with all sides are congruent, 4 congruent sides. So you drew that correctly, didn't you? Of course, anytime you're drawing something, your measurements can be slightly off because all of measurement is an estimate. Okay, so you drew a rhombus with a quadrilateral with all sides congruent. Correct? That's what I see on most of the papers. And then you drew the diagonals. And you measured the diagonals. What can you tell me about the diagonals?
They are not congruent.
They are not congruent, Margaret says. Did anybody get the same answer? They are not congruent.
Mine are.
Yours are? Yours are not?
And then
Yours are not? Yours are not? So it depends on how you drew your rhombus. Depends on how you drew your rhombus. So they're not congruent. Unless you happen to draw that type.
Unless you drew square.
Yes. So were they perpendicular?
Yes.
Did they bisect each other?
One with
how can you draw, how can you draw a quadrilateral with 4 congruent
Means it cuts it in half.
Melissa has a great question. Y'all can come back to me. Melissa has a great question. So Karen, you drew a rhombus where the 2 diagonals were not congruent, correct? Would you like to come up to the Elmo? That was a yes or no question, which I shouldn't have even said. Come up to the Elmo and show them.
Bring your paper, love.
The Elmo is over here, and sweet little Rowan told me how to do this. I push HDMI, right?
Listen to you.
It doesn't work. And I bought 2
It might be
extra
in the front
lamps
of
to
that
get more light. And it's still going.
Turn it on.
I did that. I just got my computer finally. My desktop, my room. One now. But I just got it.
Okay. So, Denise, tell me what she's trying to show y'all.
I'm sorry.
I'm sorry, then I'll let somebody else.
No, it's okay, I can
Okay.
answer, I just didn't hear it.
Tell me what Karen is going to show y'all.
She's going to show us that she drew a rhombus with 4 congruent sides, but that the diagonals are not equal.
That's what she's going to show us. So, and you measured them,
I did.
and they're definitely not congruent.
Right, this diagonal at this point is longer than this diagonal at this point.
Okay? Y'all believe her?
I don't know.
I want some discussion. I don't want just people saying, oh, sure. Okay? As
We
if you
believe
say,
her, she measured
oh,
it for us.
sure.
We're sitting here.
All right, so that table saw it, and they have proof. This table, I want you to either agree or disagree, because that's how you think, not because you want me to shut up and move on with the lesson. So, Melissa, you asked the question. Take your ruler up there, please, darling, and measure and see. All of this is still review, by the way. We did all of this in the summer.
I need this from you. Denise, you're never excused in this class.
Definitely not good.
Okay, can you tell them your measurements?
Oh,
This one?
Yes, how long was
What
that?
was that?
4 and then 2 inches.
For what?
I don't know. 4 centimeters.
4
Maybe
centimeters?
2 little slabs.
So
4.2 centimeters?
Let's go with that, yes.
Okay, and the other
was
one?
3 centimeters.
3 centimeters. So she proved that she didn't really prove, because in math we don't really do that. But it seems that we can draw a rhombus, thank you so much, that has incongruent diagonals. I don't either, but Rowan does. Yes, ma'am.
Could we say she provided evidence to support your statement?
That would be a very scientific way to say that. Thank you. She provided evidence that not all rhombi have
Good proof, Karen.
congruent diagonals. Okay? They don't have to. So all of this was brought up because Margaret asked, is a square or a rhombus also a kite? Also a kite. Definition of a kite, again, what about the sides?
Two sets.
Adjacent congruent sides. Okay, 2 sets of adjacent congruent sides. Why don't you sit up? I'm sure you won't break your neck. 2 sets of adjacent congruent sides. Does a rhombus have that? Yes. Yes. Some of you wanted to say that a kite had to have a longer diagonal than the other. 2 diagonals not congruent. Do some rhombi have that? Yes. Some. Not all. So can we say that a rhombus is also a kite?
No,
Why not?
because in my rhombus, it did.
Interesting. In your rhombus, it didn't what?
Yeah, and mine, the diagonals working.
Your diagonals were congruent. So it can't be a kite because of that. Okay. So some people say it is a kite.
No, is there not diagonal in the definition?
Not a definition, just an explanation.
Okay.
So some people say it is a kite. Tim, I want to hear your opinion.
Let's say it can't be a kite because a kite doesn't have parallel lines.
Oh, go Tim.
Yes!
Tim did it.
Reason?
A kite does not have parallel lines. In a rhombus, in a square, or parallelograms, a kite is not parallelogram.
Kite is not a parallelogram.
It's a quadrilateral, but not a parallelogram.
So where does the kite go?
Some of the quadrilaterals, squares.
But look at all the good thinking you did.
Just confused us.
Now, here's my question to y'all. Had I let Tim, and I knew Tim was thinking this the whole time because he was sitting there like this.
He didn't say anything. He was
trying.
It's right there. Just
Are y'all
look.
with me? He was trying so hard not to say that, and I think Karen was too. Trying so hard not to say that. So I tried to ignore him as best I could, but his little face was just about to burst.
I even asked him, is a rhombus a parallel? It is, okay. But I
Yeah.
never got to the other side.
So had I let Tim speak up or Karen speak up first, what would have happened to the thinking in this room? We would have stopped.
They would have stopped.
That's right.
You all would have said, oh yeah, that's right, and gone right on. Would you have ever considered all the discussion that we had? No, so it's terribly important that you know your students and you would have some kind of system so they don't shout out answers. Because once that kid shouts out that right answer, once that Tim in your class shouts out that right answer, everybody just says, oh, he's smart, yeah, that's right, let's go on.
Well, and then you still have those kiddos that don't believe it, and they just go along with it because, well, he said so, but I just still don't believe it.
That's right.
And so they don't
Or I
have,
don't see it.
yeah, I don't see it, it's not a deep understanding, so I can't ever apply it.
That is exactly right. So you have to be really careful, and that's why choral response questions really, really bother me, even though I do it to y'all all the time, and that's shame on me. But in a classroom, choral response questions are absolutely not a good strategy because Tim, Karen, Rochelle, you know, these people that are vocal, they're gonna say the right answer, and the other kids, totally confused, are gonna go, sure, got it, when they don't. Okay, so you have to be careful there. Right? So then we did.
That's where the writing piece comes in. I'm going to chime in because I've really been trying to incorporate writing. Making them write it, because that's when you separate the boys from the men.
Absolutely, great point, Donna.
Or the girls from the West.
When Deanne and I have been out in classrooms, we are looking to see whether students are writing gratuitously, because it says write whatever, or describe or define, or whether they're writing to learn math, or writing to learn science, or to deeper their understanding of math or science. So that's a real danger of trying to incorporate writing gratuitously versus the students using it to understand the math or science.
Yeah, it has to be purposeful. I see some of my undergraduates say when I have them have a writing prompt, they want to say, what was your favorite part of the lesson? Well, that's really great, but that doesn't tell them that they understand the thing. Okay. So if they stick it out the door, sometimes it'll say, what was your favorite part of the lesson? Well, okay, we love playing with the cubes, but I really don't know the difference in volume and surface area. So you have to have a purpose for your writing prompt. Okay, so then we did this activity where we had the diagonals that we talked about. I'm going to go on because we spent a long time on that. Then we had this activity where we had 36 color tiles and we had to have all of the rectangles, and we talked about the differences in the perimeter and area. And if we come to some kind of conclusion about what kind of rectangle has the largest area, if you have a set, let me say that backwards. If we have a set area of 36, which kind of rectangles have the largest perimeter?
Long side.
The long skinny ones. The long skinny ones. Why is that? Why is that, Dee?
You want it to be the longest, not the biggest area, but
Got a set area of 36. I want the largest perimeter.
So it'd be like 12 times.
I don't need a numerical answer.
Okay.
Why does a long skinny rectangle have a larger perimeter than one that's square, let's say?
It's more spread out.
Yeah, it's longer. It's the area around the, the perimeter add the distance all the way around the shape. And if you go all the way around the shape, it's longer.
Why?
Because there's more squares.
We have 36 tiles. Margaret?
The greater difference between length and the width means they're gonna have a greater perimeter.
Yes. Now her group actually wrote that on their chart paper, remember?
Yeah.
The greater difference between the length and the width, the greater the perimeter. Why? Why?
Well, when we created that really long rectangle, we're using more of the sides for each square of, because it's square area. But like with that one, that square in the center, we're not using any of its sides to add up with the perimeter. But when you get to those endpoints, we're using 3 of the sides, and each one in the middle, we're using 2 of the sides. So if you have it more compacted, we're using less of the sides than the.
Very well said. Can you tell me what she said, Catherine?
No, I'm sorry.
She was writing. Tanya, can you tell me what she said?
I think I can. I think I can.
I know you can.
So I was using 12 squares. And I said, okay, if I line those 12 squares up and do a 1 by 12, then I'm counting 2 sides of each of those and 2 sides of 10 of those and 3 sides of 2 of those. If I line them up in a 3 by 4, then I'm only counting 1 side of 6 of them, 2 sides of 4 of them, and then there are some in the middle that I'm not even counting the sides.
Exactly.
So that makes the perimeter bigger.
Very well said, both of you. So if you're looking at this picture, well, let's look at this one. On this picture, does every square have some of the sides counted?
Yes.
Yes. In this picture, does every square have some of the sides counted?
No.
No, none of his are counted. None. So the longer it is, the greater the bigger the difference between the length and the width, the greater the perimeter. Very well said, Margaret. Very well. Okay.
I can explain why though.
Well,
But now I can.
if you had the tiles in front of you, you actually could have. But this is a review. So then we talked about, Lori came in and did something on polyhedra and non-polyhedra, remember? And we talked about vertices, edges, and faces. The vertices are, in layman's terms, the corners. And the faces are the flat surfaces, and the edges are where 2 flat surfaces, 2 faces intersect. That forms a line segment, and that's called an edge. Okay? There's 2 types. There's polyhedra, and then there's non-polyhedra. Non-polyhedra have faces that are not flat. And I have a real problem with this word faces, but that's, I didn't have another way to say it. I didn't want to say sides. So faces are not flat, such as in spheres, cylinders, and cones. Okay, they have non-flat parts, surfaces. There you go.
So one of the questions on the star was,
I'm not going to ask you how you know, but okay.
last, the release, I think it was a release or
Okay.
something that I saw was about how many faces does a sphere have, or do you remember
Yeah,
that?
it's on the
Anything like
practice.
that? How many faces does a sphere have? And so my kids wanted to say 1 face. So I had a really, really hard time trying to explain.
Yeah, and I think that they want to say that because we talked about cylinders having 2 flat faces and then 1 curved face. And so they get this idea that a sphere has a curved face, I think.
So what's the definition of a face? What's the definition of a face?
In a plane or a flat?
What's the definition of a face here?
I tried to tell them that it was flat.
It is flat. What else? What's the shape have to be?
Can I answer?
Yes.
The inside of 4 of the sides, like a square, or a
Yes.
quadrilateral?
Yeah, it's this part in here, because the edges are the edges.
So does a face have to have an edge? Can you
That's
say
what I'm
that?
asking.
Okay.
That's what I'm asking. What's the definition, in Texas at least, what is the definition of a face? Because different states are different. It has to be a certain thing. What's the word I'm looking for, Tim?
Polygon.
Has to be a polygon. Has to be a polygon.
The polygons
A
that make
face
the
has to be a polygon. So are polygons, is a circle a polygon?
No.
No. So we can't say a cylinder has 2 faces. It has 2 faces, but not faces.
So we can't call them
Yeah.
faces. Yeah.
A base can be any shape.
So the answer to that question is 0.
Yes.
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 And I struggled so hard trying to explain it to them. And
Yeah.
I didn't even think about the edges, so that, if there are no edges, then there can't be a face. Can I say that?
Because a base has to be a polygon. Poly means many, gon means sides. Polly got many sides.
There are no
Right. So, faces are these flat parts of the 3D shape. That's not well said, but you know, when you get something on the internet, you have to kind of explain that it's not really right. So, let's move on here. Polyhedrons, poly means many, and hedrons means faces. Polyhedrons, many faces, okay? So if it has 4 sides, it's got several names. It could be called a tetrahedron because tetra means 4. Or it could be called a pyramid. If it has 6 rectangular sides, that's a prism. Some textbooks will call it a hexahedron, 6 faces, okay? A cube has 6 faces that are all congruent. Okay, 6 that are all congruent. So is a cube also a hexahedron? Hexahedron. 6 faces. Yes. Yes, a cube is a hexahedron. We don't call it that very often, but sometimes books will. Okay. So we have an octahedron, which is 8 faces. A dodecahedron, that's 12 faces. This is 2 and 10. Do is 2. Deca is 10. Okay, 2 and 10. Icosahedron, that's 20. Icosa is 20 faces. Okay. There's other characteristics of icosahedron, which is why the word ISO is there. Yes, ma'am.
Question, because when I was teaching this my 7th graders, when I told them a cube, I also said a square prism. So that's.
Is that okay?
Because that way they knew that it is still a prism, even though, oh, that's a cube, but it's also a prism.
Rectangular prisms, yes. Because some rectangles happen to be squares. I had a really dear friend at University of Houston who wanted the kindergarten teachers, and she wrote some modules for kindergarten teachers, to call every square a square rectangle, so that the kids would get in their heads that a square is also a rectangle. So she was in one training, and I was there with her, and she was trying to teach these, there was like kindergarten and 1st grade teachers there, you know, the elementary people, and she called it a square rectangle, and they argued with her for 30 minutes that a square and a rectangle were different. So that's a real problem in early elementary. So I suggest that you go to your PKK 1 and 2 teachers and make sure that they're using the right vocabulary, because you don't want them coming to you calling a rectangle and a square 2 distinct, completely different things, okay? Because a square is a rectangle. Yes, ma'am?
Well, not to get into another 45-minute discussion, but aren't at that lower level there, I don't know, critiques of kinder first, but I mean, is that the whole problem, is that they have to differentiate between the two? So how do they differentiate between the two if there can be, you know, if a square, so I think it's maybe where they have a hard time.
Can they tell you
that.
the different dinosaurs?
Well, my son is in pre-K, and they teach him that the square has 4 sides that are all the same side, and a rectangle has 2 short sides and 2 long sides.
Is that right?
So, well, yeah, but I'm just saying, like, they're teaching that they're 2 separate things.
Yeah.
Squares are squares, and rectangle, they have all the same sides.
So what should they
and
be
rectangles
saying
have 2
then, I
short
guess,
sides, 2 long sides.
What should they be saying?
Hang on, Rochelle. So going back to what she said, the teachers are teaching that a rectangle has 2 long sides and 2 short sides. 2 long sides, 2 short sides. If your teachers in PKK 1, 2 maybe, are saying that, is that helping you or hurting you?
It's killing me.
It's setting them up for failure on certain things. It is teaching them incorrect things. So your job should be to go back to those teachers, arrange with your principal some kind of vertical, horizontal, you know, meeting, and talk about these geometric terms, because you don't want them teaching the wrong thing. Remember in Van Healy's level, they have to be through level 3 by the end of the 8th grade. One of you in here, I can't remember who, I think it was Donna, was saying their kids were having trouble with trapezoids or something, and they were still at the visual level. That's level 0. So they've got to get through levels 1 and 2 in 3 years, and that's really hard to do, really hard.
Well, in the Kinder Teeks, I just looked it up because I wanted to know, is it in the specific Teeks? The Kinder Teeks says, identify 2-dimensional shapes, including circles, triangles, rectangles, and squares as special rectangles.
Yes.
Or call it special rectangles.
And that's new in this new set of teams.
Yeah, that's in the TEKS for kinder.
For kinder. Kinder.
For kinder.
So those teachers could not argue with our friend anymore. Dr. Grace, you hand it.
That's what Wendell tells me in Bible study, stand up and speak up, because most people in my class are deaf. I taught Montessori for 8 years, and so I actually have a question. We always had children have the physical object, and they would always have to run their fingers around it, or, and we had sandpaper objects, etc., so that they would get that texture. We never used plastic, by the way. It was always wood material.
Long time ago.
Yeah. Well, I don't know that that's not true now, but at any rate, so does that play a role in terms of children learning these things, that they should be having these objects and actually running their fingers around them and describing the characteristics?
Thoughts?
Yes. Because
Absolutely.
that's concrete to abstract.
Yeah, well, that's my thinking, but, I just wanted to verify it with the expert.
Absolutely, because if they don't have those concrete experiences, they'll never get up to high school level geometry. They just never will, because it's too abstract. They can't picture a 3D object in their head very well. Get up to the conic sections, they're lost. What's a conic section? What's a hyperbola? I don't get that. Where did that come from? Where I can see it in my head, because I actually held a hyperbola in my hands one time. Yes, ma'am.
I was just going to say that it's definitely very true, especially with the shapes, because when we were talking about prisms, and I asked, what is a box of cereal? What is it, a prism or a pyramid? And they were like, oh, it's a pyramid.
Yeah.
So I brought in a box of cereal for each class, and we took it apart. And I'm like, see, if I take these sides apart and you can do that? Yeah. So they all brought in boxes, and we unwrapped them, and it was like ding ding, like that.
That's why the geometric shapes that I had Sandra order for y'all last summer had those nets in them.
In the nets.
For you, yeah, because that is so helpful. Yeah. But you need like a classroom set, so talk to her about that. Okay, so here we have polyhedra, and she's giving me a grant. Here we have a polyhedra and non-polyhedra. These are three-dimensional shapes. We have polygons. Polygonal bases. Bases that are polygons. We have pyramids. We have prisms. There are others, but we're focusing on these pyramids and prisms. We have circular bases, not faces, but bases, which are cylinders and cones. And then some with no bases at all, which is the sphere. And this is probably, post-test material. Okay. I think.
Bathroom time? Anybody need a bathroom break?
Michelle?
Just a question. So the pyramids, only the bottom would be a base and the others would be faces.
Others are lateral faces, yes. Yes. Good question. Now, do you want to go to the little girls' room? No.
Go see him.
You got 5 minutes. So we haven't even started on parallel.
Okay, very quickly, guys, a couple minutes. Others are lateral.
Bases and all their life.
Well, I mean, I think still.
Any of the two bases.
Sort out two. I can't have doing all this mess until finally I got to this year. Now I understand. What is it? Hierarchy of subsets. When do we get to the shapes? Doesn't seem to be
I asked questions.
Figure that out.
But if you look at the pyramids on that picture,
Examples like those fast focus things.
Oh,
And countdowns, those really help.
From here, you have to switch around.
And the kids are gonna have to
You're talking about writing, it's something on the- It might be a sign. I think it's just.
they focus on specific things.
The countdown.
Yeah, we had to buy it. It's about
There's rectangular pieces of.
but you can copy. Oh, yeah. But you said specific, you know, objective.
So like that would be a really good start, because I'm getting ready, because my math departments, the 6th and 8th grade, said they didn't want a diagnostic before start, and I thought that was really stupid, so my kids are all doing like a diagnostic to see what teams they need to work on before start. So that would be something that would be.
Well, it'd be better for a diagnostic at this point in the year is the like you say, it's spiral, which is a mix of everything. And it's
There's 10 series.
And it's called Countdown to Start.
Countdown to Start. I don't know the name of the publisher. But I'm thinking, boy, are Fast Focus and Countdown and W. Rigger all made by the same people? All right. So much alike.
So we're good. Prism is rectangular.
We're good with what we're talking about.
I'll write that, so prism.
Oh, there it is. Countdown. Countdown start?
Y'all do Countdown and it's Fast Focus?
Is that like campus-wide or school-wide or what?
There'll always be two
warm-ups?
So what about
Their math warm-ups.
well, I guess that wouldn't be a prism then. Half circle. That's still a base, right?
We're focusing a lot
Well,
on.
the flat thing. The flat is not a prism.
And I'm just now just like geometry.
So any prism will
It's a
have.
free trial.
You know what I mean?
We've been doing this.
The math star. I'll just put that one.
I'll look at the step up tweaks and I'll do the, I want to show you the Fast Focus.
They would give me
Specific geometry and whatever. And then I'll. Far behind us, I think that's do every day. We're just set up like 8 problems, well, 7 to 8 problems a day. And so when we did that last time,
You know, if you get functional pages.
We could do that. They'll give me a stuff.
y'all should have done very well on this test because we had every one of these problems. We covered all these different styles. What's wrong is that kids have trouble just understanding the problem. It's very different. They have to look back. Like right now, you're working on that, and they it's asking, it's not catching here, and you're giving you this is what you're milliliters, and they want you to change it to liters. With the answer, you have to add it up in this one, and then change it, convert it to liters or centimeters or something, depending on what you're doing. And that's what they're just not reading their questions. How do I get them
Be motivated.
to go back and just look at it? Certain words drop it.
Yeah, it's a lot of interest. I didn't finish it.
I've got to get them to the fair.
Trying to get them motivated to analyze the questions sometimes.
They did much better than they did on stuff before Christmas. But almost 60% of them.
I do it on
Of course, that's a low pass.
my students all meant for that.
See, I didn't. But I hadn't taught. I mean, I still haven't taught.
I think the countdown helped them.
Guys, I want to show y'all something, and I was trying to, I didn't introduce Paula a while ago, and I know a couple of you are not in here. Paula McBride is a longtime friend of mine. She and I taught together at Madison High School. Paula was a nurse, and then she went into special ed, and then she went into science, full-time, retired as department chair there. And so anytime somebody who's good retires, and I grab them quickly, like I did with Greg, so I said, Paula, I think you'll like this. Why don't you come try us out and see how you like it? Anyway, so Paula's here, and she's one of the high school specialists. But anyway, what I wanted to show you was, in one of my feeds, there's an article here that says, a formative assessment, more than an exit ticket. And I'm thinking, how would anybody think an exit ticket is formative assessment and the only one that you use that period?
Right.
So, you know, what Browning has done, right there. So what Browning has done is what Paula and I were talking about in the back, is that, you know, she's constantly assessing, and people, I don't know how people can be teachers or whatever and not understand that. You know, that formative assessment goes on almost every minute because you're reading students' faces, you know, their body expressions, you're asking questions, and if you're not asking them with, it ends with a what?
Yes,
Anyway, Gordon Browning is a master of that, and I like what Melissa said a while ago, because she's trying us out, and I said, well, do you like us? And she said she does, and she said one of the reasons she likes us is because we're friendly, and she feels comfortable saying she didn't understand something. And that's exactly what we want all classrooms, you know, your classrooms to be like that, that student feels comfortable and saying, well, I don't understand that.
It's okay to make a mistake. Absolutely.
I tell my kids from the beginning, I'm like, it's okay to not know the answer, but it's not okay to not try.
That's right.
I want to go back to the formative assessment. That should guide your instruction. If you'll see, we're on slide 17. I have 30, and the last 10 are the ones where the activity is, so that's the time-consuming one. Okay. But I could not go on because of the questions, the discussions we were having. I needed to stop and redo some of this and answer your questions. And the questions, the huge discussion about kite was nowhere in my mind when I walked into this room this morning. If Margaret had not asked that question, we would have missed all of that rich discussion. And that's how it is with your kids. They'll ask the most intriguing questions, and that is such a great opportunity to have this really rich discussion and clarify some misconceptions as you go along. Misconceptions, okay? I'm going to go on even though not everybody is back yet. So we're talking about 3D shapes. So we have the polygons, and they called a mistake here, so I deleted it. So now it's right. Okay. We have pyramids, and how many faces does a pyramid have? One. What shape is that base?
Polygon.
It's a polygon, and it varies. It can be anything except. What can it not be? I didn't end with the what. It can't be a circle. It can't be a circle. If it is a circle, then it is a cone, and it doesn't have triangular lateral faces. Pyramids have triangular lateral faces. Okay? Yes, ma'am.
Sorry. And Craig asked this.
We're good?
No.
Way to go, Craig.
On the cone, do we call that an edge?
This is an edge. Okay. Which is confusing because it's not a line segment. But yeah, we do call that, I don't know another word for it. Karen?
I still call it a base because it sits.
But what do you call
she's talking about the rim.
Oh, the rim. I call it a lateral surface.
No, that's the part going up. She's talking about just
the rim?
Yeah.
the circumference of the circle.
I didn't even know that I'd even. She said the edge, but.
I've said the edge question and I've had a question.
But by definition, it's truly not called the edge.
Right.
But
so I guess we should revert to the circumference of the circle.
Well, I guess my other question for us was why would you be pointing that out?
I don't know. Craig asked.
Oh. Let me know what the question is. Why do we have to have a name for that?
Well, because it doesn't meet an edge's definition.
Doesn't mean it's just a.
Edges are line segments.
Yes.
Edges are line segments.
So two faces and
So I wouldn't even bring it up unless the student did. Now, if the student does, then you better.
I was trying to think of what a student might ask. What is it?
Well, do we call, they might ask, is this an edge?
right, does it come
Because
as
it'll
an
say
edge?
how many edges are.
Because it's
So we have to
a
say technically no, by definition.
Right.
But couldn't you just say?
Now, be sure we're all in one conversation here, so we're all hearing the same things. Go ahead, Michelle.
So if a student, I'm just thinking if we're looking at polygonal bases and circular bases, maybe a student's gonna get confused with why. I'm just trying to think as a student, so you can say a polygonal base because it has a polygon.
It's a polygon.
And
It's a line segment.
if it's not a polygon, it's a circle. So I'm trying to think of where a student might just come up with, well, what is the outside part?
And they may, and I have, as Karen has, called it an edge before, but technically it's not.
And so I guess I thought she was asking about the top part. Lateral surface,
That's
it's
lateral
not a face.
Right.
So you just take a surface.
Lateral surface, yeah. Somebody had a question?
I did.
I was gonna ask, on those bases, the polygonal bases, are those considered bases?
Yes, bases are also faces.
Okay, so then how come,
For prisms and pyramids.
okay, but on the circular base, those are not considered bases.
No, these are not faces because faces have to be polygons.
Okay.
Yeah.
Okay, so then that would be my explanation
These are
for,
faces.
okay, but they're
But
not
not faces.
bases. Okay.
And that came up several, I guess maybe 10 years ago when I was in Seguin. And I had a fifth grade teacher call and say, remember they had those PACS practice books that they sent out at one time?
Yeah.
She came up and she said, is this right? I mean, she was just adamant. She was in my office, red-faced and everything. She said, this is a face. And I said, no, it's not. She said, that's what they said, but this is a face. And I said, no, it's not. So I had to call TEA and get them to answer me on the phone and then send me an email in writing to explain that to her. So in Texas now, these are faces, but they're not faces. Faces have to be polygonal. There are no vertices there. So that brings up the question, is this a vertex?
No,
That's what it teaches in the 7th grade book,
No,
that it has one vertex, the cone has one vertex.
I've seen that in many books. Is
Yeah.
it a vertex?
no.
Yes, ma'am.
Kind of irrelevant, but maybe relevant, but what might change, confuse some is, you know how they create their little memes or avatars and say choose your face and it's just a flat circle. And I think that might confuse.
So the games that they're playing, see, I don't play those games, so I don't know. So now that you know that as a teacher, then you've got to address that in your classroom. You've got
That's
to
Think
address
Through
it in
Math.
your-
Think Through Math does that also.
Yeah. Okay. So now that you know all of these pitfalls, choose your base. You've got to address that. All right.
That point of the cone is called an apex, because I Googled it and looked it up, because I wanted to know. And I did it in front of my class, it's called the apex.
Now, the definition of an apex is actually the highest point. So if it's sitting on its base,
Right.
then that is the apex. If it's laying down, we still call it the apex, but it's no longer the highest point.
But can the other pyramids have an apex?
Okay, let's get back together here. Okay,
Karen, go home. Sorry, I love you.
We need Karen. Let's go back to this. A pyramid has how many bases deep?
Bases?
With a B.
A pyramid has one base.
One base, good. And what shape is that base?
It depends on the type of pyramid it is. It
Good.
could be a okay.
Nicely said. So it could be a square, as the pyramids of Egypt. It could be almost any shape, as long as it's a polygon. Okay. So what kind of lateral faces does a pyramid have, Tanya?
What kind of lateral faces does a pyramid have?
The faces that are not the face. What shape?
Triangles?
Triangular, yeah, have to be triangular. And they come up to a vertex?
Point.
They come up to a point, what do we call that point?
Apex.
The apex, good. Can we call it a vertex?
Yes.
Yes,
I'd say
because a vertex is where two edges meet.
Two edges, so there's more than two, so.
Two or more edges meet.
So, okay, I hear this side of the room discussing, this side of the room tomorrow
I'm sorry.
is the apex.
I'm drawing prisms.
Hush, Kim. Is the apex of a pyramid also a vertex?
Yes, because the edges meet.
That is made by edges, is where edges intersect.
Whereas on a cone, it's rounded, there's no one vertex, I mean, no edge,
No edges.
no edges. So
So-
that's an apex, but those are apex or vertex,
Oh,
right?
and.
Could be either one.
Yeah. So does this table agree, this argumentative table here?
Well, I have a question maybe.
Yes, ma'am?
You know, when we're teaching 2D shapes, we call a vertex when two sides or two segments meet. So are we maybe giving that definition wrong? Because when we
So
get to
maybe
this,
take out the
kids are gonna, yeah, or I would have, well, that's why I was asking them. I don't know. The vertex was two lines. Now since we have more lines, does it change?
Well, going from
Vertex.
2D to 3D does change some things.
Yes.
Okay.
So I think you're safe in 2D to say 2. Whereas in 3D, you'd have to say, well,
Two
we're
or
in
more.
three-dimensional now, so you know, that
You
changes
gotta have
some
more
things.
sides.
Bases.
Okay, going on to prisms. I want a definition of prism, a very succinct definition of prism. I have volunteers? Craig, you got a definition of prism? You want to phone a friend? Got a friend, hand up.
I'll start it with, all the faces have to be polygons.
Okay. All the faces have to be
They
polygons.
have parallel bases,
Okay, the bases, how many bases do we have?
2.
2 bases. How many bases
Oh.
did the pyramid have?
Oh, that's right. But no, that's not a prism.
How
So,
many bases
one.
did a pyramid have? 1. How many bases does a prism have to have?
2.
2. And those bases have to be actually polygons? What else? He's doing this. So they have to be what?
Parallel.
Parallel and,
Opposite.
well, they're opposite, yes, but congruent. Have to be congruent. They have to be congruent. So it's got 2 polygonal bases that are parallel and congruent. And the lateral faces here are rectangular. Whereas here they were triangular, here they're rectangular. Then we have cylinder. How many faces with an F? Faces does a cylinder have? 0. How many bases does it have?
2.
2 bases, and they are circular. Do they have to be congruent?
Yes.
They do.
Okay, so I've seen a definition of a cylinder though that says it has one curved face, because when you make the net of a cylinder, that
It's a
is a
rectangle.
rectangle. So it has a curved
But
face.
in Texas, we call it a lateral surface. Curved lateral surface. Sure.
I just had a figure pop into my brain. What if it's more like an oval? Is it
Is it
then
still a cylinder?
I don't know.
You tell me. Is it?
Well, it doesn't have a circular base anymore.
So is it a cylinder? Not in K-12. Not in K-12.
Those shapes, because remember those little.
I just thought of
squares that have
a word,
little shapes
or you have the Kleenex box now. It's kind of oval shaped.
Or the
That's the
snuff
ones
box
now.
that my
Yeah.
the lady that used to keep me when I'm not shot, yeah, she had snuff boxes that were like that. Yeah. In high school, I mean in K, whatever, in Texas, cylinders have to have circular bases. But if you go further than that, it can be a whole lot of different things. It can even have a hole in it. It just has to have a corresponding point from one base to the next. I can bring you pictures of things that you would swear were not cylinders that technically are cylinders. Okay? So, but let's not get into that because that will never cross your kids' minds for right now. So, cylinders have 2 circular, parallel, congruent bases.
Because the inside of the
The cone has how many bases? One, how many bases does a
Like
sphere
she's saying
have?
there.
Zero. How many
They're circular
faces
and-
does a sphere have? Zero. Good, good. Now we're finally gonna get to the activity. So for this activity, you're going to need one bucket per however many you want. So one person from each of the 4 tables can get some of these.
Can they eat fudge?
And I did a 3D Google search.
Was that when you talk about square and
Okay. We can come back together, please. 3, 2, 1, together. I don't have one of these for everybody. I intended for each person, for 2 people to use 1 sheet of paper. Okay? But I did have extras, so I went ahead and passed out all that I have. If you want copies of these for your students, then they can be posted on tracks or somewhere. Okay? This is actually a student activity. Sometimes with y'all, I do teacher activities to deepen your understanding that are not intended for students at all. But this one is actually one that you could take back with your students. I'm going to scroll forward real fast because I don't want to run out of time before I show you this. But I'm going to show you, don't look at all the answers, okay? Don't look.
I'm just kidding.
I couldn't remember all that in.
I'm going really fast. You can't see, don't remember. These are the teams I want you to see. Here's 6th grade. These are the current teams. Here's 7th grade. Here's 8th grade. Here's algebra. Here's 5th grade. These are all the teams that are covered with this activity. Okay? So it does go from 5th grade to algebra if you do the activity in its entirety with your kids. Of course, and you'll pick and choose for your grade level and what you're doing at the time, which ones you want. But I did want you to see, here are the teaks for 5th grade, a whole bunch of them. And, oops, went the wrong way. And here's 6th grade, 7th grade, 8th grade, and algebra. Okay? So now we're backing up. I learned if you just hold it down, it goes a whole lot faster. So you have a sheet of paper, and on this sheet of paper, it has these instructions on it. I'm going to read them to you. We have a fudge company that wants to make open-top rectangular trays. So how many faces will this tray have?
Faces.
Faces.
1.
5. Why only 5? Open top. So open top. We could say that that top is one of the faces that has been removed. Okay, even though in a rectangular prism, almost any 2 parallel sides could be the faces because they're parallel and congruent. Okay, so it's got 5 sides. You're going to make these trays that are going to be 24 centimeters by 20 centimeters. I'm going to give you some centimeter graph paper in a minute because you're going to actually cut them out and make the trays. Okay, and that's what the centimeter cubes are for. These are centimeter cubes. If you'll open them, I want you to look at them. You may take a few out. Okay, these are centimeter cubes because they are actually 1 centimeter in length, width, and height. So they're very appropriate for both math and science because of the metricness of it. Okay? You're going to have to be really careful not to get these mixed up with your base 10 blocks because the unit and base 10 blocks are also centimeter cubes, but you don't want to mix the 2 sets because then you'll be, when you need these, you won't have these, or when you need, it's just not good mix. All right, so here, you're going to, the trays are created by cutting squares of equal size from each corner and folding the remaining portion up. Okay? They want their tray to have a volume of at least 750 cubic centimeters. Also, they want to use the surfaces of the trays, those faces, for advertisement. And so they need at least 420 square centimeters for advertising space, okay? So you are going to just, you'll need centimeter graph paper, which I'll pass that out in a minute, and follow the instructions on the paper that I have for you, which that's what all of this is. I just copied and pasted them up here so you have a visual up here as well as there. So let me get you the graph paper while you read and discuss with your group how you're going to fill in or complete that paper.
I have a headache already.
Like this would be open, like the top. And then they just put the cell code. Right? Same like this.
But this is just
Like a baking sheet.
Yeah.
You should be reading and discussing with your group.
All of it except
Start with the length of side of
My mom is kind of always geometric shapes.
It feels like it doesn't work, but it does.
So see, because our end, I'm thinking our end game was not gonna be a 24. We're teaching they want. You have to figure out.
The paper's not big enough.
Yeah, the paper's not big enough. To make the tree.
Not the rest. It's not big enough.
You have scissors and tape in your basket.
scissors and
I got the 24. So you see the 24.
Hey, Brennan, you have a pencil? The first thing I do is cut out square. What do y'all think? Say it one more time. Cut out a square that's 20 and 24. Yeah. So I'm gonna do that.
Yeah, that's what I did. Well, we used to cut out a rectangle that's.
Aren't we together?
Yeah, we've got it, 20, so.
Yeah, because I'll never do this on my own.
So I need
Well, they're saying, right, but.
one more red.
So we're looking at a two-dimensional rectangle that we're gonna cut corners out of, squares out of, and fold it up to make it whatever it needs. And so what's our height gonna be at each thing to give us a volume of
How is the principal at No, how is because I think I'm gonna have to choose my son from
If I can have your attention for just 1 minute more. Your attention for just 1 minute more. This is a student activity, so please try to think like a student. Try not to use your excellent teacher knowledge. And I'm
Mine's long. I did the 24, and then so I said that. See,
That's where I'm cutting out to make it. So how can we make it happen?
And then, create a way for this equal size corner. and folding the remaining portion up to the side. So
length outside, do we need to cut out like to get 120 square things? 420 squares and we cut out the surface area of a triangle.
So the surface area has to be cut it on the angle. So the surface area of 4 sides has to be cut. I mean, I should have mentioned.
Oh, and I could have
They take out one. So like, what I have right here.
Okay, I have
This is at the base to
Okay.
There's more over here. You need it.
One out of the link.
What out of the way? 9? No.
Big table and word for like.
Still doesn't work.
So when it goes 2, I put it up 2. So keep the darkness of the line, you follow the color of the line. It's right there. It's right there. It's right there. So the length and the width will be.
You can't add anything.
If we took the width of
So this is 24 by 20? 20. Top of the street.
Yeah, you could.
Right?
So what we need to do is here's a corner.
Yeah, he is not.
I'm taking up 4, but it's to make our corners and we'll find the volume of this. So it was.
We're 20. This would be 3 times 18. No, it's 20 to 28. That's 54.
Hold on. She kind of needs to be with y'all rather than
So we're cutting out this one, cutting out one.
We should make different ones.
No, that's gonna actually.
Well, I'm the 4th grade, but.
So, yeah, they cut off from 6 to 4.
So then on one square,
And then
I don't want teaching my
4 times 3 times 2. And then we get 32.
If we move our corners in, we'll be increasing our volume or decreasing our volume.
Wait, is that like this?
Probably like a 19 by 4 and 15 by 6. I was trying to think what my 4 acres would do.
If I gave them this, they would freak out.
That's what I was trying to, how would we get them to understand that?
They're like, if I took it right because it's 18, if we're moving it back, and we're moving those sides back. Right, this is 18, this is 18.
I got it all. I can't do it, I got it. Start off as
That would be helpful to yeah, do it like then physically, once we get to the
This is the 20, 16, by 2.
So that's
So I have 32.
Times 2.
That's 64. So
And then this is the 24 side minus 4, so that's 20 by 2. Which is 40 times 2, which is 0.
they have to be square, so if you took off.
So I took the 1 out
On each one, but that wouldn't be this is the body.
Then minus 4.
Should we actually go 1 the other way or 2 the other?
Yes.
Let's try 2.
Okay, so she's saying from wherever
yeah, because I always try to
Cut out the 4, right, for it to be a square. And that would be just,
Now let's find a volume.
and then 10 of the 24, so it's 13 by 1, 2, 3, 4.
that'll be a way to
7 times 2
this would be a minus 4.
And then 10 by 5.
So now, I'm going to have a height of 2.
So you're going to 40.
We need to do that. Oh, it's double again. Because we need to get to 1, 2, 4, 20 on the sides.
Right.
So double what we already done.
Now it's left.
So that would be like twice as much.
I mean, we're just drawing out. We have to hold everything in order.
What was that volume? So you'd have to make
Okay, so then we're talking
ready to
about
go with the cube. So you would show it.
6.
Yeah, but the volume is, did you see how I had to multiply?
24 by 20, right?
Yeah, so now we have the majority of the square. We have to allow 1, 2, 3, 4, 5 more, right? Because it needs to be square. Square corner cube. So minus 9.
Yeah, it would be
Minus 9.
Not.
So
That would give us more.
split the difference.
That's split the difference.
That's right. Let's make start with these.
And mine should be, I'm going down by 2.
It goes down by 2.
So my width should be 14.
So 14 minus 24 would be 10. 9, 7.
So 100.
Okay, so now, 6 by 7, 42 by width.
Yeah.
We need a volume of what? Because how many cubes?
A volume of 7.
Okay, so now we have,
Yeah, the volume of 720 squares set against. This, the number that I was thinking is for outside.
So now, I'm gonna write them out if you wanna plug them into my calculator.
Because remember, we're taking pieces.
Oh, include the bottom, okay, so then how do that 3 by,
Take the
So when she increasing the size of the rectangular prism, increase the size.
That's what we're looking at right now. We need a surface area of So this is all 100 meters. Okay, so we're looking for a surface area of 400.
I missed that part, I just see it going up, like, wait, do you not take away, it's going up. Or just,
So this is just showing.
Yeah, you don't get that back. Well, even if they folded it, you still are gonna lose that space, right? So we're,
then I would
so
say
that's why that's why when I only count because these are gonna be just folded up, those will be gone. So it's gonna be bigger. Not with what you this doesn't work. Wait. Here. But still the same size. But we also did not take into consideration the base of this one right here. Oh, no. If I would I would have to take this out so if I sat here and I said, okay, look, do make me I would start smaller, but if we were using you know what I'm saying? Yeah, you need to create
How would you do that?
I'm thinking of space.
Right.
Just one dimension.
That's what I
See, and that's what I was saying. How would I have my students?
Surface area.
Because I think
This is 24 by 20. This is our beginning. We're a little bit better of this with this size. The last before is a CPU. So when we first put in the regular square,
We're still looking at, I'm looking at volume.
Okay, wait, if I have my 750 and get
14.
my
Right.
Same setup. Will give me 140 times 5. That's not gonna work.
So 700.
So we need one more.
Because maybe I'll put
No, there's 4 sides to these things. But if it's 14, that just jumped up over like 2, right? Does 120 mean just one side or the base?
I'm cutting this out.
But it's actually not right. Then you're getting rid of some of it.
Okay, so sidewise, we're like in this one, we put the 4 by 7. 4 by what? 4 by 8.
I'm gonna see if I can't make the smallest one using that so we can see it with
taking one square
area. So I was thinking like, this is going to be the length of the tree.
And then the other one would be 4 by 12.
So I'm gonna bring it down to a smaller one instead of a larger one because this is gonna take forever. I'm not gonna sit here and try to do the 24 by 20 squares.
You read the whole thing.
So these things.
What's her base?
She knows it's read the
Plus, whatever. that's our base, 60 by 12.
And I never say that to my students.
Yeah.
I do.
Because it says in advertising and audits, consumer products.
Because you've got me.
Right?
It's also
Yes.
60.
3 of them will shape.
Right.
But they want
Now we go back and.
2 layers, which would
And the
be
base is gonna be
6 by 7. My length don't have to be at least 6, and my width would have to be at least 7.
So we think we have to go one more down.
Wouldn't have to be at least 7. So this is where we have 4, right?
We got 40.
What is this?
Figure out.
Well, the biggest of them, that was the one by making the base, right? Because we went from 60 by
So what we should do is figure out what
to an 18 by 14. That's going to be significantly different, right?
Okay.
You just shush.
Okay, now we have this.
18 times 2, right?
No, that's the base.
So we have a surface area on the base of 252.
And then was it over there, 216?
But we did last time the 242.
So we had like 10, yeah, but so that should get us there, because maybe if I need to make one out, right?
3 times.
I want to point out that's where our original was.
Oh, really?
That is 14.
So 3 by 18. Yeah, that's a lot of
Alright, so
3 by 18.
And the other side. 14 by 3.
Going off the pattern, right?
Why do you have the
40.
figure eight? Is it cutting it out?
So if I add up all of those.
Alright, I'm done.
I'll cut out the 2 by 2. Mark that, not yours, because I'm not.
So they have this mindset, what we have to do.
So the height is as well, right?
Is that right? Is that right?
24, so that would
What I was is a winner. Okay, so then I was.
Okay, so then
So this is check.
If I was to hand this,
See,
they
that
flip
is
out
16 times 12.
so much. But when I give them something like this, if I was to tell them,
And I broke it down, and I was trying to make it in a smaller one. 24 by 10.
realize how much.
So if I gave her this, and we were making this, and I did at least 750, and how would they be able to solve the problem by making that model?
That was the original plan. Because we didn't take it straight now. So like for me, it's actually counting the blocks.
I was so proud of myself.
We figured out. Yeah, keep it.
Oh no, there's more tables too.
So we need to write. I see what she's saying, but using this by cutting it. Because if you do this, I was just telling her, she was like, yeah, that's why you
See, and like right now, I have
So you take this, and then they're gonna get tired of it, like, to figure out what.
Yeah, that's why I introduced Todd and whenever they come.
I did, I got out the cube from us, and we built it. And then I let the ones who still can't see, because we can go get the.
See, I don't have to teach all
all over four sides.
Some of them, like, so some of this is still good.
I wish my kids remembered area and perimeter and
Do we want the perimeter?
So you gotta get a volume for 18 by 14 by.
Advertise or exterior side.
And how are we figuring out?
56. That's her area.
Plus the perimeter.
Now we have to figure out.
Well, it'd be the area, we've already done the area, surface area.
Yeah, you've already got it here in the same. You have to make sure you have enough advertising space. We were multitasking with that. Yes.
Lead time what?
Yours did just that one and two, or just
Or just the one that we did.
Okay.
So what we can do is wrap all the, can we take a picture really quick?
Kind of this.
I need it. Okay, flip it over.
Okay, so
Area.
What would I use?